Okay, so let's see into the topic ionic and covalent bonding. So to start this topic, let's talk about ions. So the definition for ion is an ion is a charged particle formed when an atom gains or loses electrons. In other words, let's take a metal which we'll take as lithium. So it's got two shells and it's got three electrons altogether. It has two in the first shell and one in the second shell. So an atom becomes stable when it has two electrons in its first shell and when it has eight electrons in its second or third and so on shells. So, in order for lithium to become stable, it needs two electrons because it has only one shell. So, lithium loses this electron and becomes Li plus because it lost that one electron. If we had taken uh, um, an atom such as copper, I'm not going to draw the whole atom because it'll take a long time. It has two electrons in its outermost shell. So copper loses these two electrons to become copper, and because it's lost two electrons, it'll become 2 plus. Now, it becomes a positive ion when it's a metal, but it forms a negative ion when it is a non-metal. For example, chlorine. So, chlorine has 7 electrons in its outermost shell. Let me draw the 7 electrons. It needs one more electron to complete its shell to become 8. So an electron comes and joins here. Now, because chlorine is borrowing an electron, it becomes Cl minus. Similarly, for oxide, carbonate, sulfate, and so on, all the non-metals will form negative ions, whereas metals form positive ions. Since we now know how ions gain their positive and negative symbols, then the next question is how to write down formulas based on these ions. So let's take a compound like magnesium chloride 2. So we know magnesium is Mg2 plus from the table of ions and Cl is minus. Now magnesium has two electrons to spare, but chlorine has only one. So this electron will be used up by another chlorine. And this is how, because there is only one magnesium, we write it as magnesium. And because there are two chlorine, we use MgCl2. And this is how you come to the formula. Let us take another example, aluminium chloride, AlCl3. Now, aluminium has 3 electrons to spare. Chlorine needs only one. So, therefore, then aluminium can share its 3 electrons with 3 chlorines. Therefore, that's why the compound is AlCl3. Now that we know about ions and how compounds are found, let's look at ionic bonding. Now, if we look at the patterns that we had before, we had aluminium and chlorine. This is a metal and this is a non-metal. If we look at magnesium chloride, it's a metal and it's a non-metal. and so on. We can see that for ions, it's always between a metal and a non-metal. Therefore, ionic bonding means that this occurs between a metal and a non-metal. So let's take a look at some of the examples. A common question asked is, show the dot and cross diagram between sodium and chlorine or any other metal and a non-metal. So this is how we would draw it. We would draw all the electrons of sodium and all the electrons of chlorine. Now, the reason why it has to be a metal and a non-metal is because this creates an oppositely charged ion, because chlorine is a negative and sodium is a positive, and therefore they attract each other. So the force that happens between them is called ionic bond. So as usual, if we had done this in this type of format, we know how it would be, because there are three electrons. Aluminium has three electrons to spare. It would attract three chlorines. Here, sodium has one electron to spare. Therefore, it attracts one chlorine. And therefore, the way we would write this is, because sodium has given its electron, is given its one electron, it's going to form plus. I'm going to draw only the outer shell. It's going to have 8 electrons, because once this shell is completely empty, you have this shell which is fully complete. It has all 8 electrons. So this would become, we put brackets so that it looks neat. You'll have a plus here. And because Cl has borrowed an electron, we would show it as a cross, because we know that comes from sodium, and sodium's electrons are crosses. So in order to show that difference, we put a cross there or anywhere. And this would become minus, because it has borrowed an electron. Now that we have understood how the electron dot structure is, let's take a look at the lattice structure of ionic bonds. So this is how it would look if for any ionic bond, but specifically now we are looking at sodium chloride since it's our example. So you can see that chlorine is all the green dots right here. So these represent chlorine atoms. And you can see that it is surrounded by sodium. And another thing you will notice, that you can never have two chlorines together. It's always chlorine, sodium, chlorine, sodium, chlorine, a sodium, chlorine, sodium, chlorine, and it goes on everywhere. So therefore, you can't have any two chlorine atoms. And specifically, when you look at this diagram, you will see that six sodiums is surrounded by a chlorine atom, and six chlorine atoms are surrounded in a sodium atom. And when you add all of the atoms up, it always is a 6 to 6 coordination, and that is their coordination number. And this type of diagram is called a face centered cube lattice, and it's the same for all ionic compounds. Now let's take a look at the properties of an ionic bond. So it is a close packed regular crystalline structure. As we can see here, this is how it is, a closely packed structure. It has a high melting and boiling point as a result of strong ionic bonds. As we know, because of the force of it, because they attract each other, because one is positive and one is negative, therefore they have a strong ionic bond, which results in higher melting points and boiling points. They conduct electricity when molten or dissolved in water. This is because the ions are free to move, and when voltage is supplied, they can move without any trouble, because when they are in solid form they can't move anywhere, they're just stationary. They are soluble in water but are insoluble in organic solvents. Also, the solids will only dissolve if it is energetically favorable to do so. Because the ionic bonds are so strong, it takes a lot of energy to break them. And so there is some kind of payback energy. And this happens when the ions are surrounded by water molecules. When it's surrounded by water molecules, there are new forces of attraction that release energy called the hydration energy. If this hydration energy is uh, greater than the ionic bond energy, then they are able to break them. And those are the properties of ionic compounds.